Product engineering, productionization, and additive manufacturing technologies for strategic defense applications. Under his leadership, the Center for Additive Manufacturing has been at the forefront of innovation, integrating cutting edge additive manufacturing solutions into defense systems to improve efficiency, performance, and reliability. His expertise, vision, and contribution are instrumental in driving India's progress in smart manufacturing and next generation production technologies. We are indeed privileged to have him with us today to share his insights and expertise. Please join me in extending a warm welcome to Dr. Jason Rosario Zegaras, sir. Welcome, sir. Yes, sir.
Meantime, just good morning to all of you. We would like to give you a really great privilege for me to be here today. This is where they might be. It's like to be here. This my very famous day. It's very great. So in this presentation, I will just take you. Okay. Okay. Yes. Okay. Okay. So it's fine. So actually, the purpose of the course is on smart manufacturing. Just I would like to throw some lights on this smart manufacturing. What are the activities which is being taken throughout the world? So I just want to bring some insights into what India is doing on smart manufacturing, how we are working on smart manufacturing, and some concepts which are making the manufacturing smart. Okay, so we will go with the presentation. So manufacturing competitiveness. So it is the uh, measuring scale to see that what is our manufacturing status. So manufacturing competitiveness is refers to a nation's company's ability to compete effectively in the global market by utilizing its resources to produce high quality goods at competitive prices, driven by factors like innovation, technology adoption, and efficient operations such as lean manufacturing, skilled labor, and the supportive environment. So, if you see the key drivers for manufacturing in competitiveness, it starts from innovation management, policy and guidelines, and government investments. You can see recently there are a lot of government policies has come, Atmanirbhar Bharat, Vision Bharat, all these things. And skilled manpower, there's a lot of manpower skilling activities are going on. And materials availability, government is taking a lot of initiatives to get materials which are not available in the country. And energy costs are coming down, quality management, development of markets, economic and financial tax systems. So these all together affects the manufacturing competitiveness. So few case study, a few this thing. What is there in where India stands? India is the second most attractive manufacturing hub globally. So among the leading manufacturing countries in the world, India is standing the fifth. So India is projected as one of the fastest growing economies in the world, which is in line with India's ambitions of becoming the 5 trillion economy in the next few years. So this is the way actually India is growing presently last 10 years. So the biggest manufacturing economies, if you see, so after China and USA, Japan, India is in the fifth position. So it is one of the very greatest, fastest growing economies in the world. So how and in India, another one is the Innovation Index, Global Innovation Index (GII). So where India stands. So India is now in the 39th rank, which was there in the last 7, 8 years back. It was in the 70s, the rank of 70s. So it has gone in the last 10 years. It has, because of the promotion of lot of startups in the country, it has gone to the rank of 39. So the global innovation index is calculated based on these parameters, what are shown on the right side of the presentation. So all these factors which comes together, education, number of institutions, infrastructure, market, everything comes together and affects the global innovation index. So India is growing very fast, and the top four destinations in the world, the 2018 to 23, which are the fields, like which are the top best destinations to invest for the anybody in the world, like that if it comes for semiconductor field, India stands second. The people wants to invest in India in the semiconductor field. That is a growth rate of semiconductors in the country. Renewable energies, India is second, and electrical vehicles also India is second. So that is the shows the manufacturing competitiveness of India the last 10-15 years. And India is the fifth largest economy. Is global competitive index is 39. Logistic performance index is 38. Innovation index is again 39. With all these indexes, whatever um, what you say, the indicators, based on that one, India is the fifth largest economy in the world. So with these few words, now how to improve the manufacturing competitiveness in the country. So there are few strategies which have been projected improve the manufacturing competitiveness in Indian MSMEs through smart manufacturing. So smart manufacturing is use of modern digital manufacturing tools. Robust manufacturing, it is slightly different, is capable to handle uncertainties. Advanced manufacturing using state-of-art machine tools and processes, and innovative manufacturing use innovation in manufacturing. This first into the market. So innovative manufacturing, I have one slide. So which I worked personally in that one of the drive India has taken. So how to improve the innovation in the country. So there's lot of things has happened. I will tell some case studies which has happened recently. So how to promote innovation in the country. So that is one is the startups which is coming. Second, it is actually as a DRDO as a whole, it has set up DIA centers of excellence. DRDO Industry Academia Centers of Excellence. So it has kept even in your zone, it is IIT Jodhpur is having DIA centers. So any projects which somebody wants to take, which is a translational research projects. So translational research projects is that when you say the TRL level, technology readiness level, you know about TRL level? Yeah, some idea, no? So when technology readiness level, say for example, whatever the research which are being done in the lab level. So I do some experimentation for project work with something innovation. So those things are TRL level 1 and 2. So I'm doing like a PhD work, which I'm doing some number of experimentation and proving out something, TR level 3. So any PhD work after that, TR level 3. So when it goes to the industry, whatever the PhD works, whatever the research works being done, it will not cannot be taken in the industry. So that is the way where India is lagging. So those researches which are being done by the brilliant minds of the country is not coming into the market. So there's a big gap. So the industries needs the technology at TR level 7 and 8. So in that case only they can do it. So PhD people doing at 4 years or 5 years or 3 years, whatever they are doing, they do the experimentation, do at lab level, show the experimentation is working, stop, finish. After that, nobody is there. Next person will not do that work because it will not give any advantage to him. So he will stop the work, he will take a new work. So then professors also not able to continue because the student would have left. So it is stopped at this. So the foreign countries, except saying for Germany, USA, Japan, Singapore, and UK. So all these countries has taken an initiative how to promote this TR level 3 to 5 or 6. So that is called translational research. So this translational research, how it is being done in Germany is that it is done by Fraunhofer institutes. Many of you may be having an idea how the Fraunhofer institutes are working. You know, Fraunhofer institutes are working in it's a partnership model. So academia will fund, it will be kept in academia, but funding is from the industry. So industrial problem is solved at academia. So it is a translational research. Whatever the problems of industry is taken at academia and it be solved. So that is called translational research. So those people will take the TR level from 3, whatever is left by the academia, the PhD students, whatever work on that area, from 3 to 6. So doing number of experimentation, repetition, testing, and field level testing, all these things is being done by this translation research group. Because you may think why industry cannot do. Industry cannot invest time on anything. So for them is industry may be ready to invest money, but industry is not ready to invest time. So for them, time is very. So when I invest this much time, whether the output will come or not, if they don't know, they will not invest. But if I invest this big amount, but output will come, means they will invest. So that is the difference in industries. But academia invests more time, but it don't invest money. So how to bridge the gap? So that is a translation research. So academia, you put your talents, your people; industry, you put your money. So together the projects. So that is what I told. The similar model, actually in the USA, it is called National Network of Manufacturing Institutes (NNMI). So those things at during the period of Obama, President Obama. So that time it was initiated National Network of Manufacturing Institutes. So there were 40 institutes was planned, 40 to 45 institutes in the first lot in 2012 to 15. So in that period, 5 institutes was being already started. In that, one of the thing is additive manufacturing. So, so there the additive manufacturing got the complete light of it. So that time when Obama announced that additive manufacturing is one of the disruptive technologies which is going to change the world in the future. So when it was announced and given a lot of fund as for doing translational research, then the complete scenarios changed. A lot of people have started working in additive manufacturing. So many industries, so many equipments. We can see that additive manufacturing. So that time I started to work on additive manufacturing, 2012, 13. So I can see the differences, what happens in last 10 years, 12 years, what happened. So that is the importance was given at the time. So USA, I told NNMI. In Germany, it is Fraunhofer Institutes. In UK, it is called Catapult Institutes. Catapult Institutes. So same type of translation research, Catapult Institutes. In Singapore, it is called A-Star Institutes. Okay, A-Star Institutes. So India, after recently in 2016-17, we invited one of the specialists from different parts of world who was working in this type of translation research. We had a meeting, so took idea from them, and it was proposed as a policy and those things. So innovative manufacturing, the word was coined at that time. Okay, so that is the background of this one. So where we want to work on innovation manufacturing. So towards that one, lot of funding was happened. So that NNMI now changed into America Makes. So in similar lines, Make in India came. So these are similar to that one. So with that, the trust whatever America gave, it's the same way India is given the trust to make in India. So Atmanirbhar Bharat and all these things has come based on that. Okay, so the manufacturing industry outlook says that what is the key trends in manufacturing competitiveness? It is latest 2025. So talent, AI and generative AI, clean technologies, smart technologies, and supply chain. These are the main areas which need to be focused for smart manufacturing. Okay, so now coming to the smart. So what is smart manufacturing? So it is have several domains. So starting from the left side, digital manufacturing, use of robotics, and coming to the green manufacturing, it should be green, sustainable, and using Six Sigma concepts, value engineering, lean engineering, total quality management. Coming the other side, Industry 4.0. I think many have been aware of Industry 5.0 also is coming. Cyber physical systems, industry Internet of Things, cloud computing, big data analytics, artificial intelligence, machine learning, virtual reality, augmented reality, digital twin. All these buzzwords are comes together to make the manufacturing smart. Okay, some we see just a glimpse of all these technologies, then we go. So green manufacturing, it has three R's: reduce, recycle, and reuse. The next level is sustainable manufacturing is having six R's: reduce, recycle, reuse, recover, redesign, and remanufacture. So it is sustainable manufacturing. The circular economy is the next level where we are taking back the uh, where there's no waste goes out. Maybe the batteries, I think you might have seen in some centers, you have to put back that old batteries into the same center, Nokia previously, those things that we have to give back, the thing that will go for recycling. So that is called circular economy. Okay. So green manufacturing is commitment to use fewer environmental pollutants and natural resources. Green facilities also make every effort to produce less waste, carbon emissions, and try to have little impact on the environment as possible. So one somebody can say that additive manufacturing also comes under green manufacturing. The reason is that the waste is less. So considering that waste is less and the energy is less, considering that 2 points, additive manufacturing comes under green manufacturing. There are some technologies like flow forming and type of things where the material is formed instead of machined. So such type of technologies also comes under green manufacturing, where we want to reduce the cost, reduce time, and improve productivity. Sustainable manufacturing, as I told, economically sound process that minimize negative impacts, environmental impacts, and while conserving energy and natural resources. So that is called sustainable. It is one step ahead of green manufacturing. Circular economy, I told that it is using a sustainable model that extends the life of use of the materials, goods to minimize the waste and so it will be like recycling and that type of activities. Okay, coming to quality in manufacturing, the next block, which is Six Sigma. So maybe everybody might be knowing about Six Sigma. It is a concept as well as it is a direction of waste and bringing all the process control within limits. So the process that make use of statistics and data analysis to analyze and reduce the error of defects. Lean Six Sigma is a focused team focused managerial approach that seeks to improve the performance by eliminating resource waste and defects. And the third part is the value engineering. It is the systematic organized approach to provide necessary functions in a project at a lower cost. So we can see a little bit about these things. Six Sigma is multi-dimensional structured approach, improving processes, lowering defects, reduce process variability, reducing costs, increasing customer satisfaction, and increasing profits. So it is a philosophy as well as it is a methodology. Lean Sigma is a philosophy, management philosophy. Six Sigma plus Lean. Okay. Value engineering can be defined as an organized effort directed at analyzing a designed building features, systems, equipments, and material selections for the purpose of achieving essential functions at the lowest life cycle cost. See, actually, value analysis, I think you may be aware of value engineering. No? So it is function by cost. So function will be more, cost should be less. So in there is one concept called DMAIC: define, measure, analyze, improve, and control. So these concepts to be used in value engineering to improve the functionality of the component. So there is one, first of all, the functional analysis will be there in the value engineering. So in functional analysis, what is the function of a pen? So you have to explain it in 2 words. Somebody can tell. In 2 words, you explain what is the function of your pen. write text. What is the function of a eraser? Erase anything. Erase pencil marks. Something like that. So if you want to see precisely, then which is not useful in things, we can cut off. Understood? It is only to write. I don't want any additional things on that one. So I can improve the reduce the cost, but function will be maintained. Okay. Other things are only cosmetics things. So I'm having a big holding and big whatever the additional things which come in color and all these things are cosmetics. So how much you want to reduce, you can reduce. Otherwise, it can be like a cosmetic. So there the value when you take a big system. So okay, pen is okay, is something small we can have it. When you consider a big system like a missile system or a space systems, there will be n number of things which is unnecessary things will be there inside a system. So when we want to see why this is needed, so you have to question each and everything. Why this wall is needed? Why this bracket is needed? Why you cannot come? See, for example, to put a bracket, they will bring your system, then put one bracket and attach it by welding. So it's not needed. It can be incorporated. It can be attached. It can be combined. So all these things to be thought of. But people what as a this thing, each department will come and add their parts into that one and they go. So they will not see any holistic way. So there actually the value engineering plays a very important. So we have to see each and every aspects of design whether it is needed. It is in a holistic way. It's not only mechanical engineers should see only mechanical, electrical engineers should see only electrical things like that. So electrical engineer will come, I want this component to be added, just will add it and go. You will not see whether the same function is already available or not. So such type of that is a value analysis. So value analysis can be done in two levels. One is at the initial design of the new product, or it done at the existing products. So if it's already some existing product is there, we can take the product and do value analysis. Or if you want to do as a new product, it's a different value analysis. So two type of things are there. So it can be done. There are some certification courses are there. People can be interested. They can get certified. I am a certified value engineer. So it is some certification. You have to write some exams and you have to be certified. In Six Sigma also some black belts, green belt, all these things are there. Some people interested, we can even white belt they will give first. So then say for green belt I have to attend some 1 week classes and write one exam. So I am got green belt and stopped. Okay, coming to industry 4.0. So it is something like I think you all may be knowing 1.0, 2.0, what are the changes has happened and up to 4. 4 is like computing, IoT, big data, AI, and smart machines. All this comes under 4. Then it is extended to 5, where that human-centric machines, robots, and people reconcile. So those things is adding to the 4.0 beyond it is beyond 4.0. This more or less human-centric, human as well as robot working together. It is not only automation, only robots will work. So intelligence is being shared by human as well as robot. So they are also working on par with humans. So these are the technologies. So as I told in 2012, this is a McKinsey report in 2012. It has come 2012 or 13. So there, these are the technologies being listed as disruptive technologies. So in this, if you see mobile internet, so I think after that you can see how much changes has happened in the signal info, 3G, 4G, 5G, whatever this thing, and automation of knowledge work, Internet of Things, cloud technology, advanced robotics, autonomous and near autonomous vehicles. The other side is again energy storage, batteries, next generation genomics, 3D printing, advanced materials. All these things has come. So we'll see some little about automation and other things. Then we go into 3D printing. So industrial automation is use of control system, computers, robots, and information technologies. for handling different process or machineries in an industry to replace human. So if you see the global automation market, what are the areas like the automation industry is estimated to generate around 238 billion US dollars worldwide in the large segments belonging to process automation. The process automation is one of the very major industry which is making use of automation. So this is something like how the market for automation is growing. So it is growing very fast, and it is a CAGR of 9.8%. So in the Indian industrial automation also is growing very fast. So that is data shows. Okay. So what are the benefits of automation and robotics? It will improve the productivity and increase output, saves labor and reduce dependency, save energy and materials, improve quality and accuracy, speed up time to market, and keeping business competitive with others, helps to keep pace with other order demand, improves safety, reduce work weeks for labor, reduce factory lead times, and offers many opportunities. So globally, if you see, the robotics and automation is the changing the global work environment. It is revolutionizing the future of manufacturing. So if you see, what is the risk assessment? So because of this robotics, where people will get affected. So if you see in this slide, automation risk. So food preparation, future 60% like. So if you see that range, so food preparation is the area where, because of robotics, the human people will get affected. Affected means it's not like a labor that people will lose their jobs, because all the things will be done by automation. Food preparation is one of the highly automated industry. Construction, cleaning, driving. So all these things comes. If you see even hospitals, surgeries, everything is the risk assessment, automation risk by job type percentage. So when you see that whether automation is a boon or bane, so automation could eliminate 120 million jobs by 2030. The revolution of automation finds machines replace men in the mines and mills of America without replacing their incomes or their training or their needs to pay the family doctor, grocer, and landlord. This is by John F. Kennedy. So it is replacing a lot of human beings with their automatic systems. So, but what we got, you see the left side, it is a blue collar job now converted into a white collar job. The same, it is done by robotics, and people become white collar job. They are working on systems. Say that this is to be done, it will be done by the robotics. So that is the advantage we get. So anyway, this benefits automation. It saves time, reduces chances of errors, lead to operational stability, reduce more overheads, and so on. So notable trends in India manufacturing sector where it is getting improved. So one is export driven expansion. Additive manufacturing is recently getting picked up. Industrial Internet of Things, advanced robotics. India is now started using. In some slides, it will be there that how India is using the robotics. Digital technologies, focus on backward integration, focus on forward integration, and collaboration. So with these things, a lot of collaborative efforts are now being done. So it is like a hub and spoke model. So it is like I told no the DRCO, the DRDO Industry Academia. It's like hub and spoke model. Like hub and spoke model means like for example, MNIT wants to be one having some expertise in some areas, but a major project is proposed by one institute. So here that is hub institute. The spoke is MNIT can be one of the in they can be a part of like 10 institutes will be involved in one single project. Previously, what happened? One institute will take project, whatever they are having the capability, they will do that one and close the project. So they will take only the area which they are having expertise. They take the project whichever level it is they are capable, they will do it and close the project. Now it is not. It is up and spoke. So wherever the talent is there, it will be brought together and it's working in a collaborative mode to for the final product. So coming to the intelligent manufacturing, it is again smart manufacturing, all this industry 4.0, everything. Industry 4.0 is the current trend of automation, data exchange in manufacturing technologies. It includes cyber physical systems, Internet of Things, cloud computing, and cognitive computing. And industry 4.0 and digitization have simulated the growth of automation among industries and so on. So these things like intelligent manufacturing is again, it is like a vision of the smart factory. So how the smart factory works. So what are technologies being to be used in a smart factory? So these are the areas like autonomous robots, simulation, Internet of Things, cyber security, additive manufacturing, augmented reality, big data analytics. So these are the areas which are coming as a building blocks for a smart factory. So this is same industry 4.0. So enabling technologies for 4.0 is, and you can see that augmented reality is being used in a lot of areas. Even we started working on augmented reality in some of the areas where we can train the people with what you say, um, that HoloLens type of things where we can be assisted. Like for example, the training process will be assisted along with doing that work. Say for example, he has to pick the one, the training that assisted that lens solo lens will say that you go and pick, then you go and pick, then it will say that you have picked. So it is like a interactive mode. It will be working. So that is like augmented reality. So this again 0.0. So just I skip all these things which is already discussed. So this again Internet of Things. So what are the benefits of industrial Internet of Things applications? Which is segments? We can see it is not only manufacturing; it is going for facility management, asset management, security operations, logistics and ecosystems, customer preference and behavior, service and predictive maintenance, quality control, all these things, packaging and shipping, production flow monitoring, condition-based alerts, all these things. So the data is being used. So cloud computing, so it is all the information is stored in a cloud. So we got all data, whatever is needed can be taken from the cloud. It's like smart city, a smart hospital, a smart highway, smart factory. All these concepts are being evolved. I think now so many places it is being used. So with which is all the data is available in the cloud, it can be taken and can be used for manufacturing. So this shows the size of the cloud, how it is growing. So from now terabyte, petabyte to exabyte, zettabyte, yottabyte, and gonobyte. That is a level of cloud data is getting generated and it is being used. So the seven industrial Internet of Things trends in manufacturing. What do you say? Load optimization, augmented reality, GPS tracking, performance tracking, problem solving, virtual reality, real-time adaptation to change, and autonomous vehicles. These are the areas where industrial Internet of Things is playing a major role. So if we see the robot installation in the world, so it's like 2022, it's showing 553 into 1,000 units, and in 2023, I think slightly it's reduced. I don't know what is the reason for reducing, but it is the data. So slightly it is reduced from last year. And annual installation of robots in 15 major markets. We see previously some 5 years back when I took the data, actually I was having one more presentation that time. It was taken the data older. India was not in the list, but India now it has come in the list. It is now in the sixth position, where the annual installation is getting improved in India also in the robotics. So this shows the robotic installations in the India also. 8,510 robotic installations are there in the country. So where the robots will be used the next 20 years. So it is say that the telemarketers, accountant auditors, retail salesperson, technical writers, real estate sales agents, machinists, so on. So all these health technologies, all these areas the robot is having tendency to use. We skip. So robots, maybe it can be an industrial robot or it can be a non-industrial robot. Again, the non-industrial robot, it can be assistive, non-assistive robots. So assistive robots are used in operations and those in surgeries type of things. It's being used very much, and so on. So some of the areas where it shows that in industrial, aerospace, drones is one of the major area. I think last Operation Sindhu, you might have seen how the drones are very much used. So how the robotics has played a major role. So if you, I think somebody was explaining, if any institute, if you go, any big institute, they're having their one drone lab. So they are having one drone lab separately. People are working on drones. So that is the trend you can see in any education institutions. So this is again role of robots in manufacturing or doing job without any fatigue, continuous 24 into 7 operation. It can do any hazard environment it can use. It can be used without any base and repetitive jobs can be done and so on. So it is being used in many areas like robotic welding, assembly lines, chip placement, circuit board soldering, and packaging, etc. The future trends in robotics, there are some few areas where smart robotics and AI-driven defect correction. So sometimes any defect in any welding or something, how to do the correction. So smart robotics is being used. Digital twins in real-time simulation and optimization. So we can make a digital twin of a robot and do all type of this thing, and then it can be implemented. Fully autonomous mobile 3D printing factories. So their robots are being used in locomotion. It's being used, and collaborative humanoids. So they actually like it is working with humans. So that is one of the great advantage of these smart robots. And again, drones, aerial robots. Okay, so this is the major advancements in robotics. Collaborative robots is one of the major things which is being used in industrial robots. So that you can see global trends in robotics, AI and machine learning, robots, collaborative robots in new applications, mobile manipulators, digital twins, and humanoids. Humanoids is next generation things. So collaborative. Nowadays, all these measurements are being done with collaborative robots. It's assistive, so we can move the arm. It will keep on taking the data.
Sir, how this robot is different from the traditional robot?
No, it is a collaborative. Two robots will be used, I think, because it's like the work shine will be done by two robots. It's a collaborative mode. Like if at all one big beam is there, I want to lift the beam. I cannot lift it with one robot, so I'm using two robots. So one robot should not go fast, and one robot should not be slow. So it should see that it should able to speak to the other robot. So what is the way it is lifting, and it should be able to communicate and take it. Then only it will be moved up. Otherwise, so other same way the collaborative robots for different applications for measurements and this type of the welding to be done. So for example, automobile industries. So the welding is done with the collaborative robots because one side one robot will be there, or two robots will be there, other side other robots will be there. Both should not go in same place and collide. So it will communicate with them.
So basically, we can say that for the mass production, the concept of the
Yes, one if one robot is not possible, it is like a collaboration mode. It should be worked. So then it should the working scheme also should be in collaborative mode. So the complete the work cell should be in collaborative mode. So all the robots, it should not just like that blind robot. I will go something, other robot will come and it means gone. So it should be able to understand what is my distance, what is his distance. So artificial intelligence plays a very important role in robotics. So it is the way of how the control in robots is no autonomy, remote control with human beings, no autonomy, no sensing and this thing, and no autonomy, but some sensing is there. Like it touches me, it sense that it is touched, so it will stop, something like that. And fully autonomy and advanced autonomy. So that is type of generations in the robots. Robots are being used in several applications. Amazon is one of the major user of robotics. And coming to virtual reality and augmented reality. So you may be aware of these two differences, no? Virtual and augmented reality. Hmm? So children will be playing car and they are putting maybe that virtual reality tools will be there, but it is not going to affect anything. So that is a virtual reality and augmented reality. Yes. Maybe it's some messages such as okay. It is not visible in the online. Hmm? Screen is not visible. Yes. So this is share color screen. Entire screen. No. स्क्रीन ऑलरेडी सेट है camera is you accept. Right for the beginning, because that would be like again. There is some issue. In case me, yes, sir. Share. Oh, no, put just this one. Okay, no? Okay. Now, okay. But it's actually the punchline is saying is full screen is not visible. That's why. No. Yes. Okay. No, 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 no. Okay. Okay. So just we see about the virtual reality and augmented reality. So both are used very widely in training for the service people. So what are the services, how they are getting trained? So it is one of the very important tool being used. So I think when I prepared this slide some 10 years back, when I saw this information, it was new to us. But now I think if you go into any mall and scan the code, you will get that details of the complete thing. So that is something. Even now, if you show that particular product, I think that lens, Google Lens, and those things. If you show the product, it will show that what is the cost and what is everything. So that is a same thing about virtual and augmented reality type of things. So industries expected to face the most disruption by immersive. These technologies are called immersive technologies. Okay. So where we can see the healthcare and medical devices. That is a major thing. So it's going to use these immersive technologies in a very wide way. And education, workforce development and training, services they are using, manufacturing, automotive, marketing, and advertising, and so many other areas. So you can see that healthcare and medical device is one of the major area. So that is important. So if you say now anything artificial intelligence, deep learning, machine learning, all these buzzwords now it is being used in all the institutions. So uh, where we are getting the data? So data is one of the important thing in any artificial intelligence. How we are generating data, what is whether the correctness of data, all these things plays a very important role. So if you're making the model, it should work based on the data available with you. So if the data is good, it will be working fine. If data is bad, complete thing goes off. So digital twin, it is again a virtual representation of a physical object, structure, or system that incorporates real-time data from the entity that it represents. Digital twin can be used to analyze performance, to conduct simulations, and to identify potential problems with their physical counterparts. So previously, what we do, anything we want to do, we do only simulation. So that is the only tool when we want to represent the complete physical system. We try to do it in only simulation. So simulation sometimes there are when there are multiple domains are involved. That time simulation not able to handle such thing. Though it is like a co-domain simulations, like that, so many things are there, but it will also take one or two domains, not many domains. So, but when it comes to digital twin, so it takes all the things. So many things can be integrated together. So it is completely representation of a virtual representation of a physical object. So complete all the things like it will have sensors, it will have computing, cloud computing, this virtual reality, visualization capabilities, and all analytics, artificial intelligence, all integrated together. So to get a digital twin. So nowadays, very good impact has been done in a digital twin. So that is coming up in a very big way. So this is one of the sample case which we are working on some development of a like a 3D printing robotic system. So how the digital twin is created? Actually, it's already created recently. It is completed. That is a picture shows it. Some predictive models are created initially. Then these models are trained and machine learned, and that data is given to the actual system, and the digital twin works. So robust manufacturing, I told in the beginning. So it is able to handle uncertainties. So, like for example, processing times, equipment failures, repairs, government investments, product demand, and so many things affect that one. So, how the manufacturing is robust. So, that is the way the selection of processes are important. We have to select the process such a way that it is robust. Say, for example, I'm coming with a new technology, so which is not proven. So I want to implement in particular applications. So suddenly, if the technology is not able to handle the situation, if numbers are more, it cannot able to handle the situation. Complete that product cannot come to the market. Completely affected. So then changing the lines, everything is difficult. So that's the way. So that's the reason the industries will not fund on some new products, new technologies, unless the technologies are proven and matured. So these are the so that is the robust manufacturing. So it should be robust enough to do the manufacturing. So advanced manufacturing, we see that. So, like laser technologies, composite manufacturing, collaborative robots, additive manufacturing, non-destructive evaluation and 3D machine vision, wireless monitoring surveillance, micro manufacturing, and multi-material manufacturing, atomic level deposition, all these things. So, it all make a paradigm shift the last 50 years from conventional factory to a digital factory. So that is a thing which came in the smart manufacturing. So now just we are entering into additive manufacturing. We see some of the additive manufacturing technologies. Additive manufacturing is one of the highest growing market in the last 10 years, which is growing very in multiple times it is getting growing. And one of the thing is that it is being tried to being used in several uh, functional or final applications. Previously, like when it's not robust, like additive manufacturing was not considered as a robust manufacturing process, but now people started using as one of the robust manufacturing process. That is a thing happened in last 3 to 4 years. So what the advantage we get is design to manufacture to design. So any parts we think we can able to manufacture. So these are some of case studies which large area additive manufacturing comes into picture. So their machines are custom built machines. So world largest 3D printer, Stargate at Relativity Space, USA. At this point, I will say that in DRDO also there is one largest printer in the Asia has been printer, which unfortunately I was involved in that project. So now we could able to build 2 meters height systems, uh, metallic systems with robotic printing. So that is Asia's biggest printer. It is getting installed another 1 month time. It will be installed at my lab. So that is the thing. So like that, we are also building bigger size systems. So it is large format additive manufacturing is one of the area where aerospace and defense is focused. Because other automobile are small components. So when it comes to space and defense, additive manufacturing, large format additive manufacturing is one. So anyway, you may be knowing all these technologies, 7 technologies, such as skip. So yeah, here actually I want to say some certain points is that there are a lot of new areas are coming out of this additive manufacturing. So if we say thermally conductive polymer composites, electromagnetic interference shielding polymer composites, biomedical polymer composites, self-healing polymer composites, responsive polymer composites. These are the things which are new areas which are being done with additive manufacturing with different technologies. So we can able to build new technologies using additive manufacturing. So that is the aim of this one, which is it's a field which is opening out a lot of new areas. So this is one of the NASA's report where additive manufacturing is used for several applications. We can see that it is used mostly on propulsion systems. If you see any of these components, most of the components, 99% of these components are used in propulsions. So propulsion area is one of the main area where additive manufacturing is used. Reason is that in propulsion, the materials used are very high temperature materials. And there are a lot of intricate features for cooling. So there are a lot of conformal cooling channels, all these small injectors, all these things, which are very difficult to manufacture with conventional way. So additive manufacturing plays an important role. So I think actually in April, I think DRDO released one press note saying that hypersonic engine of 1,200 seconds was proved, tested. So I was involved in that project. So that engine was made with additive manufacturing process. So it is having a lot of conformal cooling channels and everything. It was done with additive manufacturing process. So India also is progressing very well in additive manufacturing. So these are some of the other things which are being used in additive manufacturing. Multi-material printing. So the beauty of this thing is that the outside shell will be one material, inside shell will be another material. So I think some people are working in this area in MNIT, I came to know. So like outer is inconel material, which is high thermal properties. Internal will be a copper liner will be there. So, so multi-material printing is one of the important area. So where actually even we are also working in some methodology to work on multi-materials because the material properties will be different. So it is very um, uh, technology intensive area to work on these things. And 4D printing is another important area where actually the fourth dimension may be like time or temperature, which is used in the smart materials printing and those things. So that is 4D printing. So smart materials are being used for additive manufacturing. So another is lattice structures and infiltration. So I think additive manufacturing can make lattice structures. So everybody may be knowing about that. So in these lattice structures, we will infiltrate with some type of polymers or some type of soft alloys, so that we can change the complete vibration signature of these structures. Depends on the polymers used. You can completely change. So whenever you want damping should happen in particular frequencies. So we can tune such a way that we can put certain polymers into that one, so that I can have frequency damping in particular zone. So that is beauty of having this type of structures. Propellant printing. So propellant itself can be printed for any small ammunitions and that type of things. Previously, it was used to be casted. So now it can be printed. So that is one of the area. Micro printing is another area where additive manufacturing is very widely used. So because people used to think additive manufacturing features are very big, thick, and those things. Then we can want to make small features like in tens of microns. So additive manufacturing is in most of the mobile things. The antennas, patch antennas are made with additive manufacturing. So apart from that, it is being used in implants, prosthetics. In prosthetics, I can say that in June, no, yes, June first week, actually, we have developed one prosthetic leg, prosthetic foot for All India Medical Sciences. It was published in newspapers, everything. It was published in all the everything. So that is a positive food which lot of additive manufacturing things has gone inside. So where the cost of imported thing is 2 lakhs and it has reduced to 15,000 rupees. It's indigenous developed, designed in DRDO, and the first prototype was printed in my lab. So that is a thing. So it was released. So it is being used in prosthetics, bioprinting, some 3D printed garments and embedded electronics. So in garments, there will be a lot of electronic things will be there. When a soldier is walking in sunlight, it will get charged. And in the night time, he can use that charge for his mobile or some type of communication systems. So 3D printed garments is one of the area. Customized armor with built-in communications, wearable sensors. So one lab in IIT Kanpur is working in flexible electronics. So wearable sensors, printing sensors directly on the skin, and energy harvesters to capture solar energy and small electronic devices. So in defense applications, there are lot of things: high entropy materials, functionally graded materials, high temperature materials, and artificial intelligence and smart materials. So that are some of the applications of additive manufacturing defense applications. And some of the areas which are being used in smart, coming to now smart manufacturing, like advanced materials, which is using in biomimetic materials. So I think nowadays cars windshields are coming, which can be like self-healing. So if you have a crack, it heals on its own. The crack will not propagate. So they are self-healing. So the self-healing materials where there will be some polymerized healing agents will be there in between. When it's open to atmosphere, it is just it closes the crack, so that the crack will not propagate further. So that is the self-healing materials. So this some joining technologies also. Cold metal transfer is another additive manufacturing technology. It's a joining technology where metal is transferred in a controlled manner. And these are some of things integrating robotics and with 3D printing. So that is another area now we want a big print large format printing and those things, integrating robotics with 3D printing. So under that area that we also started working some areas that I'll show something. So it is coming into printing with robotics. So robots are used for printing. Robots are used for some type of part printing, and delta parallel robot based 3D printers are there, which is printing some objects. And you can see in the robotic printing, the top figure, that some type of structures is done by material extrusion process. And even buildings are made with large area additive manufacturing. That you may be aware that some, even previously they told only 2 floors we can make. Some recently somebody told they are making 4 floors, 4 or 6 floors with additive manufacturing. So these are deposition-based additive manufacturing technologies and robotic DED. So I told this 2 meter engine, 2 meter component was done, which is based on a DED process. Structures are made with robotic arm. And this is something like multi-axis printing or robotic printing. This is a system which is called hybrid system. So where we can do in these machines, we can do uh, printing as well as machining. Both can be done. So whenever we do printing, we may not able to get good finish. So then we follow with machining. So multi-robot concurrent printing can be done with multiple robots, collaborative robots. And so this is a relativity space is making that a big rocket motors with additive manufacturing. So they, I understand they did with aluminum. So we are working with doing with inconel material itself. So that is direct energy deposition based additive. Yeah. This is a robot which we have developed. So this is a project. So we can see that it is a robot. It's having a printing of composite materials, continuous composite materials, and this is the biggest robot in the country to make composite materials 3D. So this is having a size of 2 meter by 2 meter by 2 meter. So this is a frustum which is made of, it's a 1 meter height and a diameter of 70 mm. So it was made with this robot. So this robot also is going to come to our facility in another 6 months time. This is the robot system which was completely developed in our Indian Atmanirbhar Bharat. So this is something like totally integrated automation. It's not only machining process is automated, the complete scheduling, e-commerce, everything should be automated to get a smart factory. So this is again industrial automation overview. So the future of automation, what? So we can get all virtual organizations, virtual entertainment, cashless banks. It's already started, cashless banks, cashless driverless factories, driverless cars, GPS-based location identification. Now it is holiday. Anybody now still. Actually, when I visited abroad in 2013, one person was asking to go for a particular location. He came to the reception and told that this place I want to go. So then he shared that place to uh, the driver, and he took, and actually his room was in the back side of the same hotel. So he walked to front, then he took the vehicle and came to the back side of his room. He said that fact the place he's supposed to go. So he came out, then he got dropped in the place. Then he told where it is. This is the place what you are showing. So people doesn't know where it is. Actually, that is based on completely GPS based location. Now it's already in India. So at the time it was astonishing for me because why how it is they are going only they are depending on all these things like that. Now at the time people were telling that in Japan if a person was not able to go home, he told that that GPS system is down, so I could not find way to go to my home. So that situation is there today also in India. So people, Indian new person coming to any place, he cannot go to the destination without knowing the GPS location. So that is situation. When I started 10 years back, it was astonishing. Why even they don't know how to go to their home like that. Now it is happening in India itself. That is a GPS based location identification. Additively manufactured food. I think now, I think lot of railway stations I could see that automatically if you press what I think the food will be made with additive manufacturing. They put all the ingredients and it will be served to you immediately. Whatever way you ask, it will come immediately. Additive manufacturing. And robot friends. So tomorrow your friends may be your robot. So I am having friend with this robot, that robot like that. That is the future. So today we are talking like as the GPS I told like 10 years back I was thinking. So today robot friends may be laughing maybe with us. Maybe after 10 years the children will say that I have a robot friend. So that is maybe the situation. So it will be become possible to run overseas factories. It is happening. So overseas factory because the additive manufacturing, any person he can give print from this place to any factory. He'll be monitoring one place. He'll be in India, so he'll be having centers at US, UK, Japan, whatever may be. So you will see which are the systems are free at this moment. So then, if you want to make a component, you will give a command from here to that particular number with that particular IP address. The data will be transferred to that thing. The printing will be happening without any data transfer to their systems. So that data security is maintained. So that is important. So the person who is there in that lab cannot able to see the data what is it printing. So it will go. So it get printed after completion. He will take it out, pack, and the address whatever sent, he will send it. That's all. So he can make utilize the facilities all over the world. It's not only country, all over funding to start the, but it will have the risk of 90%. And then it will come on the 90% may fail also. So, but this is my achievement plan. So, for example, I want to reduce weight. So, for a system, it is having, it takes example of 1 kg. So, my target is 300 gram. So, I will not be able to reduce the weight from 1 kg to 300 gram at this stage. First of all, I will try to reduce to 900 gram. I am sure I can reduce 900 gram to 700 gram. I think I have to do some experimentation. I have to take some help to 700 gram. 700 gram to 500 gram, I will take it to third step. 500 gram to 300 gram is very difficult. I see. I may achieve it. So it is having 4 different slots. Okay. So it can be done in that mode. It's called figure of merit. FOM. Figure of merit. So what is my figure of merit? I will achieve these targets in levels. So you can make a project proposal also in that. So it is not that I am not able to achieve 300 grams, you are failing. No. So now projects are being done in that. So you can get involved. Just the list is there already. Somebody can work on that DRDO website is listed. Ready for taking up in any academic institutions is completely listed. But area sensitive. It's not like project criteria will be given there to work. The areas, 3D printing, so for example, my area I have given 3D printing of components, micro 3D printing. I have given that area. So in micro 3D printing, what you want to do? So for example, I want to develop a pressure sensor with micro 3D. So if you come with a project, so we will see what type of pressure sensor, what is the range it can work. So whether somebody has done or not. So all these things we will see, and if it's your project is a new, it is likely it is a new project. So it is already listed in that. We can pick it up which project you are, which is based on your expertise. And one more thing, there are some PhD scholars, you can take the projects from there so that it will be useful for you to take the next level also. For example, after my completion of my PhD, what I'll go first institution. So for the institution, when I go, they will ask what projects you are having, what is your. So these things will be helpful because you have worked on that one with your focus. So that will be helpful to project it to an MP or to. Then you can make a proposal to get. But individual project cannot be. So that is government decision. So as it goes through some institute, that's money to be maintained by the institute.
Like any this level to implement the automation industry. There are any risks involved on the basic level.
Any person there will be risk. It's not this nothing is there. All the things is happening, but how you are mitigating that risk is important. So what are the mitigation technologies? So see, for example, the technologies which just I was telling about the GPS. So it is used in particular technologies in mobile, like in autonomous systems, autonomous vehicles. So autonomous vehicles without GPS, can you think of? No. So I want to have an autonomous vehicle. So if you think autonomous vehicle is there, the risk for autonomous vehicle, if in the beginning, if I start is, the risk is only risk. So it is a major risk. So it is very critical risk. So the level of criticality is maximum. So then the enabling technologies which are coming, it is supporting to that. So for example, GPS system is one thing. Sensor-based systems are another thing. What is my sensors? So I have a sensor which can able to sense only 1 meter. This is sufficient. Enough. So whether I am having any laser-based sensor, or whether laser technologies can be used. So those are the technologies. So whenever some risk is getting generated, definitely the enabling technologies will be getting. So that is a way it is keep on. If we say that risk is there, we stop it means nobody can help. Whenever the risk is there, how we are mitigating the risk? What are the ways to mitigate the risk? What is my plan to mitigate the risk? So that is should be there. So that it will be supporting the technologies. So that way, most of our technology which are presently is there.
We found it. Can I make the comment?
Please, sir. Yeah.
Maybe that way, when we are going for this also, I can understand from which stop that basically the entire thing is addressed. That means it is also learning. At each point of time is monitoring. What is the preceding stage? So if something goes,
No, sir. Thanks. Good, sir. No, sir.
whenever the tragic, it's probably a tragic was a smart manufacturing. And then when that kind of autonomous manufacturing of whenever you are incorporating the autonomous, it's always monitored. And the man-less vehicles, the pilotless aircraft, every kind it's basically monitored. And that technology is already there. Whenever you see that the car control system is already. So that is there. If any tragic is supposed to get interviewed, the immediately corrective action is also communicated from AI, and corrective action is suggested, and the actuator is there, and then that actuator actuates it, and it gets it. But ultimately, there has to be some kind of life. That is a predictive maintenance.
Sir, nice.
Very nice to do this. So, yeah, also Mr. Kumar, how are you going to, after lunch, he will be having a meeting, and after that, he will be visiting Myanmar, but why don't you, your department also? Because he is a great man, so therefore it will be very good that whatever metallurgy department is also very equipped with a very good scientists are there, they are doing good researchers, these young guys, they are very good researchers also in their own field. So materials field. And then these materials are manufactured, he is the director. Dr. John is a great scientist actually.
So, Manish. Thank you, sir. Thanks a lot for your very insightful and very informative deliverable talk. So now, on behalf of the organizing committee, I would like to call Professor Benanti sir and Dr. Jinesh Kumar Jain sir and Dr. Yashwant Puri sir to come forward and to give Dr. John Visaria sir a token of appreciation.